Hello, amazing tech explorers. Today we're diving into the exciting world of advanced MLOps, the skills that top tech companies are looking for right now. Let's start our journey. Multi-Tenant ML Platform Best Practices. Resource isolation. Use containerization and namespaces to separate tenants completely. Each tenant gets their own compute, storage, and model-serving resources. Security and access control. Implement role-based access control with strict data governance. No tenant should access another's data or models. Scalable infrastructure. Design auto-scaling groups that can handle different tenant workloads independently. Think of it like apartment buildings. Each tenant has their own space, utilities, and security, but they share the building infrastructure. Scaling MLOps for hundreds of models. Model registry. Centralized catalog with versioning, metadata, and lineage tracking for all models. Automated pipelines. Use CI/CD with templates so teams can deploy models without manual intervention. Monitoring at scale. Implement centralized monitoring with automated alerts for model drift and performance degradation. Like managing a huge factory, you need assembly lines, monitoring, and inventory management working together perfectly. Deploying ensemble models in production. Microservices architecture. Deploy each model as a separate service with a coordination layer that combines predictions. Load balancing. Use weighted routing to distribute requests based on model performance and resource usage. Failure handling. Implement fallback mechanisms. If one model fails, others can still provide predictions. Like an orchestra, each musician plays their part independently, but a conductor brings it all together into beautiful music. Managing model dependencies and environment compatibility. Containerization. Package models with all dependencies using Docker. This ensures consistency across environments. Version pinning. Lock specific versions of libraries to prevent breaking changes during updates. Environment testing. Automated tests that verify model behavior across different environments before deployment. Like shipping fragile items, you package everything carefully with bubble wrap so it arrives exactly as it left. Implementing online learning in production. Streaming data pipeline. Use tools like Apache Kafka to process real-time data streams for model updates. Incremental learning. Update models with new data batches without full retraining saves time and resources. Model validation. Continuously validate model performance against holdout data before deploying updates. Like learning a new language. You don't forget everything you know, you just add new words and grammar rules as you encounter them. Now, let's look at the tip section. Start with small learning rates and gradually increase based on model stability. Content moderation system design. Multi-model approach. Combine text analysis, image recognition, and user behavior models for comprehensive coverage. Real-time processing. Use fast inference models for immediate content screening with batch processing for detailed analysis. Human in the loop. Flag uncertain cases for human review and use feedback to improve model accuracy. Like airport security, multiple checkpoints catch different types of threats with human agents for complex situations. Building federated learning systems. Distributed training. Each organization trains locally on their data, then shares only model updates, not raw data. Secure aggregation. Use encryption techniques to combine model updates without exposing individual contributions. Communication protocol. Establish standardized APIs for model sharing and update synchronization across organizations. Like a group project where everyone works on their part at home, then combines results without sharing their personal notes. Hybrid recommendation system design. Collaborative filtering. Analyze user behavior patterns to find similar users and recommend based on their preferences. Content-based filtering. Analyze item features and user preferences to match similar content. Ensemble approach. Combine both methods with weighted scoring based on data availability and user context. Like asking both, what do people like me enjoy? And what matches my interests? For better recommendations. Computer vision for manufacturing quality control. Multi-stage pipeline. Raw image capture, pre-processing, defect detection, classification, quality scoring. Real-time processing. Edge computing for immediate decisions with cloud backup for complex analysis. Continuous learning. Collect edge cases and retrain models to handle new defect types and manufacturing variations. Like having superpowered eyes that never get tired and can spot tiny flaws humans might miss on a busy production line. Multimodal conversational AI platform. Input processing. Handle text, voice, images, and video through specialized pre-processing modules. Context management. Maintain conversation history and context across different interaction modes. Response generation. Generate appropriate responses in a user's preferred format, text, speech, or visual. Like a smart assistant that can see, hear, speak,